Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a basic operations on discrete time signal of problem number 3. So let's see what is given in this question. Now, look at this question. What is mentioned? Problem number 3. For the given discrete time signal, obtain. These things we are going to find out. For this one, question x of n is given. In this question, the x of n value is given and we have to obtain all these three parts using x of n. So now, in first case, what is mentioned? X of n plus minus of x of minus n. Here we use two properties. First property is time reversal and the second property is amplitude scaling, because after x, or you can say this whole x of minus n is multiplied by minus 1. Here 1 is not mentioned, which is nothing but we have to consider here minus 1 is multiplied with x of minus n. Now in second case, 0.5 into x of n is mentioned, which means here again we are going to use amplitude scaling property. And in third case, what is mentioned? X of 2n. Now here the 2 is multiplied with n, which means here we are going to use a time scaling property. Now how to solve all these questions, we'll see one by one. But first of all, look at here, what is given in x of n? Well, x of n is the discrete time signal, that's why you will get amplitude only at a particular instant of time, and in between any two instants amplitude is always 0. Now at instant 0 amplitude is 1, at 1 it is 1, and on 2 and 3 the sample value is having amplitude 2 and 2. So now we'll find out solution of part 1. So this is our x of n. Now what we want, first of all, you have two choices. Either you go for amplitude scaling or else mirror image or time reversal property. You can apply any one of them. First of all, we will use mirror image or time reversal property. What do you mean by time reversal property? We are going to multiply minus sign with each and every sample given in x of n. So minus sign is multiplied with each and every sample present in axis or an x-axis. So 0 into minus sign or minus 1 is simply 0. 1 into minus 1, answer is minus 1. This will be minus 2 and this will be minus 3, which means all these three samples now shifted on left hand side after multiplying minus sign with all these samples. Now what you will get? This 1 is shifted on left hand side, which means 1 is multiplied with minus 1, so answer is minus 1. So this sample is shifted on left hand side. So this is the position of minus 1. This 2 is also shifted on left hand side and the position is minus 2, and the last one is 3, that will be also shifted to left hand side and the position is minus 3, and this is the origin. Now I will mark the amplitude. Now on origin and at 1 we have amplitude 1 1, or sample height or sample amplitude is 1 1. So I will mark amplitude 1 on origin as well as on minus 1, and on 2 and 3 amplitude is 2 2. So at these two places I will mark the amplitude 2 2. Now look at here, all the samples are now shifted to left hand side. What is the next step? We are going to find out amplitude scaling property, or we are going to apply amplitude scaling property on x of minus n. Now here x of minus n is multiplied with minus 1. As I discussed earlier, x of minus n is multiplied by minus 1. Means what? All the amplitudes now multiplied by minus 1. So here the amplitudes of all the sample is positive, but if I multiplied minus sign with it, then all the amplitudes will become negative. So I can say that 1 1 2 2 is now available in third quadrant, that is origin amplitude is minus 1, next minus 1 amplitude is also minus 1, and minus 2 minus 3 amplitude is minus 2 similarly. So I'll draw the graph first and then you can understand where this graph will lie. So this is our graph. Now what is the next? We have to add our original function with this obtained function, that is this x of n is added with minus of x of minus n. Now look at here, plus multiplied with minus, answer is minus, or you can say simply just add these two results. So look at here, we will start from rightmost bit or rightmost sample. Now here at 3 amplitude is 2, but look at here, at 3 amplitude is 0. So can I say at 3 here amplitude is 2 and here amplitude is 0. So 2 plus 0, answer is 2. Now at 3 I can say my amplitude is 2. Now look at the next two samples. Here at 2 amplitude is 2, but here at 2 amplitude is 0. So 2 plus 0, answer is 2, which means at 2 what you will get, sample having amplitude 2. Now look at here on 1. At 1 amplitude is 1, but here at 1 amplitude is 0. So 1 plus amplitude 0, answer is 1. So which means at first instant our amplitude is 1 only. So at 1 you will get amplitude 1 and at 2 you will get amplitude 2. So I will draw that part first and then we will move on to next. Now look at here, I have plotted at 1 amplitude is 1 and at 2 amplitude is 2. Now we'll move on to origin. At origin here amplitude is 1, but here amplitude is minus 1. So if we add these two amplitudes, then what we will get, 1 plus minus 1, answer is 0, which means at origin you will get amplitude 0. So at origin your amplitude is 0. Now move on to left side. Now on left side, this x of n is having amplitude 0 because no more sample is present on left hand side. Or you can say the amplitude before 0 is 0 or before origin is 0. But in x of minus n, in minus of x of minus n, what we can see? Before 0 we have some amplitudes, like at minus 3 we have minus 2, at minus 2 we have minus 2, and at minus 1 we have amplitude minus 1, and here we have amplitude 0. So what we can say, that 0 plus minus 2, answer is minus 2, but this minus 2 is available at minus 3. So I can say that at minus 3 instant our amplitude is minus 2. Let's move on to second sample, that is minus 2. At minus 2 here, at minus 2 here also we have amplitude 0 and here we have amplitude minus 2. So 0 plus minus 2, again you will get a minus 2 amplitude. And at minus 1 here you have amplitude 0 and here you have amplitude minus 1. So 0 plus minus 1, answer is minus 1, which means what I want to say, if we don't have anything on left hand side, then we can directly plot this graph as it is on left hand side because we are going to add these two samples. So I will complete that part first and then I will show you the last final graph of first stage or first part of this question. So look at here, as I said, we don't have anything on left hand side of x of n, so amplitude is 0, and we have some function on the left hand side of minus of x of minus n. So amplitude 0 with the function, answer is function. So same function I have plotted on left hand side. Similarly, look at here on right hand side. In x of n we have some function, but in x of minus n, that is in second function, we have amplitude 0. So function plus 0, answer is function. But look at the origin. Here we have amplitude 1 in x of n, and in minus of x of minus n here we have amplitude minus 1. So if we add these two values, plus 1 and minus 1, what you will get? They both will cancel each other, which means at origin your amplitude is 0. Now this is the first part solution. Now we will solve a second part of this question. Here we have 0.5 x of n. Function is multiplied by 0.5, or you can say the amplitude of this function is multiplied by 0.5, which means we are going to perform amplitude scaling. Now Here the amplitude is multiplied by 0.5. So we directly multiply 0.5 with each and every amplitude present in x of n. So 1 into 0.5 result is 0.5, which means after multiplying 0.5 with x of n, at 0 and at 1, the amplitude will be half, or you can say 0.5, because 0.5 into 1 is 0.5. Now at instant of 2 and 3, we have amplitude 2, 2. Now if these 2 multiplied with 0.5, then amplitude will be 1, which means at 2 and at 3, after multiplying 0.5, you will get amplitude 1. So if we are multiplying 0.5, or you can say this 0.5 is nothing but half, or half is nothing but this whole x of n is divided by 2, or whole amplitude is multiplied by half, which means our whole graph amplitude goes on decreasing by value of 2. So same thing we are going to apply over here. All the amplitudes will be divided by 2. So 1 and 1 will be now available at half, and 2 and 2 will be now available at 1. So I'll show you the resultant diagram. So look at here, all the amplitudes are now divided by 2, or you can say multiplied by 0.5. So you will get at 0 and 1, these 2 amplitudes is now replaced by 0.5, 0.5, and these 2 amplitudes are now replaced by 1, 1. So this is the solution of second part. Now we will move on to third part of the question. Now the third and last part of this question. Here the question is x of 2n. 2n means what? We are going to perform time scaling property. Now in this time scaling property, if the function is multiplied by alpha value, and if that alpha value is greater than 1, which means our graph is going to be compressed. Now I've told you the shortcut method also. As I discussed, this 2 is multiplied with n, which means we are going to divide all the samples by 2. So we'll start with a 0 first. So 0 is divided by 2, answer is 0. So this sample is available at origin. Now this 1 is divided by 2. So this 1 is now available at half. This 2 is divided by 2. So 2 gets cancelled. So new location of this 2 is 1. And this 3 is divided by 2. So answer is 3 by 2. So its new location is . So origin amplitude will remains at origin. This one amplitude, which is 1, is available now at half, and next 2 amplitude, that is 2, 2, is now available at 1 and 3 by 2. So I will draw the graph first, then you will get the idea how to represent the answers. Now much more important, in time scaling property, amplitude will not get affected, which means amplitude will remain same, only time will get change. So if your alpha value is greater than 1, which means your graph will going to be compressed, and if your alpha value is less than 1, which means your graph will be expanded. And how to perform a compression and expansion? Just divide this value, that is alpha value, if it is multiplied, and if n is divided by alpha, then just you have to divide it. Now look at here, as we discussed, if alpha value is greater than 1, then graph will get compressed, and if alpha value is less than 1, then graph will get expand. Here the alpha value is 2, which means graph is now compressed. Now how it will get compressed? It is compressed by this alpha factor, which means you have to simply divide this value. Now in this whole process, amplitude will not get affected. So this is all about the third part. This is the way to solve all the numericals which is asked in discrete time signals, or asked in basic operations of discrete time signals. Now we will solve a different varieties of numerical in upcoming videos. So for that, stay tuned to Ekeeda and subscribe to Ekeeda. Thank you so much.